am Elias. I am 7 years old and I am in second grade. This is my presentation of the Roman numeral system. Roman numerals are a numeral system that originated in ancient Rome and remained the usual way of writing numbers throughout Europe well into the late Middle Ages. It was used by most Europeans for nearly 1,800 years, and there's a map of the Europe and Mediterranean region in 1328, the late Middle Ages. I looks like 1, so that is how it came to represent 1. The V came to represent 5 because when 5 items are counted on the hand, a V is formed between the thumb and the pinky. X. Well, X used to be 50. However, L took its place and became 50. How X came to represent 10 is not entirely clear. One theory suggests that X was derived from one V or 5 placed on top of another upside down V. Thus, the two V's formed an X. Another theory suggests that when counting to 10, Romans did so by making 10 vertical marks and then crossing them out with an X in order to easily count groups of 10. C came to represent 100 because it is the first letter of the Latin word for 100, centum. M was adopted for 1,000 because the Latin word for 1,000 is milli. Now that you know all the basic numerals, we need to represent other numbers. Well, you put two numbers together. When a bigger number is before a smaller number, you add them. Here are some examples of that. 3 is equivalent to I in Roman numerals, since I plus I is 1 plus 1 plus 1, which equals 3. 153 is CLII in Roman numerals, since CLII equals C plus L plus III, which is 153. 2,182 is equivalent to MMCLXXX1 I in Roman numerals. 2 M's makes the 2,000. The C makes 100, and then LXXX is 80. Then the 2 I's make the last 2. Wait! Can you just use I to represent 4? Well, the answer is no. I'll talk about it in this rule. The rule is that when there are 4 same numerals in a number, you have to simplify it. How do you simplify it? For example, how do you simplify 90? It would be LXXXX. That goes against the rule because there are 4 X's in a row. But I'll talk about it in the next slide. To simplify those numbers I mentioned in the last slide, we will need to use the subtractive principle. That's why I'm introducing it here. Well, when a smaller numeral is before a larger numeral, then we subtract the smaller numeral from the bigger numeral. Then we can represent numbers like 4, 9, 40, 90. And here are some examples of it. These examples all go against the rule in the last slide, so they have to be simplified. Anyway, here are the examples. L, X, 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 X equals XC, which is 90, since XC is C minus X. So what? We do 100 minus 10, and that's 90. C L I is C L I V, which equals 154, because we do V minus I, which is 5, minus 1, which equals 4, the last digit of the number. MMCLXXXXI is MMCXCII, which equals 2192, since LXXXX is XC, which is C minus X. 100 minus 10 equals 90. One moment. We can't use the subtractive principle to represent really big numbers like 4,000. We can't use 4 n's. I talked to you about that in one of the other rules. Well, we use the multiplicative principle. Basically, a horizontal bar above any number is 1,000 times the number. And here are some examples. M with a bar above it is 1,000, and add on that 1,000 you have times 1,000 equals 1 million. Well, CLIV is 154, so we put a bar above it, and then we do 154 times 1,000, which equals 154,000. Now it's your turn to answer some questions. Here are these questions I want you to answer. Light travels 186,282 miles per second. It can go 7.5 times around the Earth in that much time. 1 second. What is 186,282 in Roman numerals? When you are done, you can click on the link below to see the answer. Now, you have a bonus question. What is 299,792 in Roman numerals? As you can see, that's how fast light travels, kilometers per second. It's still in a vacuum. Well, I'm not going to represent this in Roman numerals for you, so you need to do it on your own. It's not in the link. Isn't there a number missing? What about 0? We haven't talked about 0 yet. The number 0 was not featured by the Romans simply because they had little use for it. When trading in the market, nobody went up to the baker and asked for no loaves of bread. Of course, the concept of 0 did exist in the form of nulla, Latin nothing, to express an absence of something. But unlike the modern numbering system, which needs zeros to have meaning, like 10 and 403, the Romans could construct all of their numbers from combining the 7 basic Roman numerals listed in the table. Well, for similarities, I can't think of anything except for that we can use one to represent the other. And, of course, they are both number systems. Well, there aren't a lot of similarities, but there are lots of differences. I've made a chart about them. As you can see, we are comparing Roman numerals and Hindu Arabic numerals. The first difference is that Roman numerals don't have a 0, but on the other hand, we have a 0. The second difference is Roman numerals don't have a place value system. For example, MM is 2,000 since both M's represent 1,000, although they are in different positions. When a bigger number is before a smaller number, you add them. When a smaller number is before a bigger number, you subtract them. CIV is 104 since C plus V minus I equals 104. Meanwhile, on our side, a digit's position determines place value. A sequence of numerals such as 13 or 768 is read as a whole number. For example, 1,001 is in the thousandth place, and then zeros in the hundredth place, zeros in the tenth place, zeros in the ones place. And here's the last difference. Roman numerals are cumbersome, limited, and inconvenient in general. But our new number system is simple, easy to use, and also it's more complete. As I talked about in the last slide, Roman numerals do have some limitations and flaws. I'll talk about them here. There are 3 main limitations and flaws. Number 1, the absence of the concept of 0 and the place value system forced the Romans to adopt the cumbersome system with numerals that represented 1, 5, 10, 50, 100, 500, and 1,000 as described above. Number 2, the Roman numeral system did not have a way to numerically express fractions. There goes another difference. The Romans could only express them in written form. For example, 3 out of 8 was written as tres octave. Number 3, the Romans did not understand or explore the concept of irrational numbers like pi, which severely limited the Romans in geometry because much of geometry rests on an understanding of pi, the ratio of the circumference of a circle to its diameter. Thank you for looking at my presentation.